Okay, we want to do optimization on a backend component or do improvements on the performance in specific. What is backend, by the way? So B stands from backend, and it is basically a software that runs on a server. Server is a computer, just simply a computer. So it can have, like any computer, it has memory, maybe, I don't know, 8 gigabytes of RAM, and CPU, maybe 4 cores, and 2 gigahertz, like this. I think like this. But what is exactly this software? I can tell you, in the past I used to create softwares and deploy them like this. So it was basically a computer or a server, and on the server we used to have a backend app / DB app, DB engine with the database itself on it, and also it was a full stack app, so front-end app also used to be there. So on the other hand, when a user was requesting us like this, we used to give or receive the request and send back everything, including the front end, the UI, within that server. And it had a backend and also a database, everything in place in that computer, which is not a good pattern nowadays because it has some major drawbacks. For example, this server is limited in memory and resources, maybe also some peripheral storage like this. We can identify it has probably maybe, I don't know, 500 gigabytes of disk. It can be SSD also, which is a faster kind of a storage. But still the problem is that it is limited. And if you try to install everything on it, first of all, everything, including, for example, this database engine, would consume some of these resources. And the other problem is that we are putting all the eggs in one basket. So if, for example, database engine stops working, the entire system would stop. A better solution is to just isolate them and split them into different computers. So a backend to only consist of one application. Even better is that to split even that application into separate domains, if it is possible, and then it should only handle that part of the business. For example, if you have a system like an e-commerce system, a backend component or backend software can consist of a domain of user interactions, for example, user service. So another one can handle maybe, I don't know if it is an e-commerce cart service, like this. So I'm splitting per domain, per different logics that are grouped and connected to each other, and I'm making different computers or dedicating different computers with dedicated software. So this way, my computer would have much more performance in doing just one responsibility. Okay, now back to the performance optimization. What we can do now, if I split them, it's not just about performance right now, but now I have the freedom of making multiple instances of the same service, which we call it scalability. This means that we can have different computers with the same software, in this case user service, running concurrently, and they can handle user requests in parallel. But before talking more about having redundancy, in the other words, we can do some kind of optimization within this software as well before making it redundant. So a user service, actually we don't know what is inside this piece of software, but what we can do with one computer and one software running on it, we can go through the software itself and see how it's working. For example, we can check the software's algorithms and data structures. If it is running a specific task, maybe we can optimize that by improving those algorithms or using coding best practices. So this is very important in the system design. If you are designing a software, you should make sure that you are designing a correct data structure and you're choosing the best algorithms and the fastest ones to prevent bottlenecks. The data structure and algorithms is beyond the scope of the system design, at least in this course. But we would take a look later on in the database or caching topic in this course. But for now, we want to concentrate on the provisioning the hardware in specific. And we assume that the software that we have written here is optimized and there's no bottleneck, no problem in the source code itself. Okay, back to the question, how can we make this user service or this software that is running on a server, and we call it a service or a backend software, faster? One easy way, or let's call it the easiest way, just to add more resources. So if it is 8 gigabytes of RAM, you can just simply say or dedicate 16 gigabytes of RAM. Or if it is using 4 cores, or the computer has 4 cores, you can give it or provision 8 cores maybe, or maybe with higher frequency, like 3 gigabytes. If it is on HDD hard disks, you can just switch to SSD. It is an easy win, but the problem is that it's limited. You cannot go beyond a specific number. Maybe, I don't know what is the exact or the maximum possible memory that you can install on a computer, but let's assume it's 1 terabyte. But first of all, are you sure that your software can consume all the resources and it would not be idle? For example, if you use Node.js as backend language, probably 8 cores would be a waste of resources, because we know JavaScript runs on a single-threaded single core. So 1 core would be enough in that case. And also, it's a matter of costs. We cannot just provision as much as it's possible. Sometimes this is too costly for us. So if it is, for example, 3 gigahertz, and if I want to make it 8 gigahertz, I'm not sure even this frequency exists, but this kind of CPUs would be much more costly. And there's actually a chart that I can draw for you to understand it better. So imagine if it is the computation power. Let me make it bigger. And if we have some sort of cost like this, more computation power means more cost. And it's not a straight line actually, but it is like this. So it exponentially grows. And at some point it would become so costly then it doesn't worth it. So you as system designer, when you want to ask your company to provide or provision some resources, you should know exactly at which point the software needs what kind of resources and what would be the best choice to just reduce the cost. So maybe there is a point here, I don't know, based on some statistics and some experience, I can say maybe this is the place that is the best configuration for my software or my backend computer. And maybe this means that, I don't know, we can map it to 1 or 2 core CPU or 4 gigabytes of memory. And it can be just calculated somehow on papers, but at the end of the day, it really depends on the software itself. And you should run some sort of testings to see how, by giving more power, more computation power to your server, will your software become faster or not? And if it doesn't become faster, so maybe you can stop provisioning more power and you can cut the cost at that point. Okay, what we have learned so far is this process of giving or provisioning more hardware to a computer that runs an application. We call it vertical scaling or scaling up or down. Let me write it down somewhere. So scaling up or down. If it is up, it means that I'm giving more resources. If it is down, I'm reducing the resources. And the other name of this scaling would be vertical scaling. So by provisioning more resources on a single computer. But there's another kind of scaling, and we call it scale out. So let me write it down here, scaling out. Or another term would be horizontal scaling, is by duplicating the computers. So if I clone this computer that has exactly the same software running, I'm just scaling out. So now I have 2 computers that runs the same software. This way maybe I can cut the resources, maybe I can provision the minimum required resources. For example, 4 gigabytes, 1 CPU, 2 gigahertz, and maybe 100 gigabyte of memory, peripheral storage would be enough. And the same configuration maybe for another computer, like this. and 4 gigabytes of RAM would be enough. Now I have 2 computers, but how do they work? Actually, I need something in between that distributes the traffic between these 2 services. So this is another concept of system design, and we call it the load balancer. So basically, load balancer is a computer that has the load balancer software installed, such as Nginx, and its responsibility is to sit between the users, the end users, something like this, users, and your infrastructure. So it will distribute the traffic from the users to your resources. So a request comes in, load balancer decides to send the request or forward the request to one of these computers based on some logics. Another request comes in based on the logic that it has. Maybe this time it would forward the request to another computer, which is idle and less busy. Other benefits of this approach would be if one of these computers fails, like this, the load balancer is smart enough that identifies this failure, and from now on it will forward all the requests to the existing healthy instances. So this way we are improving also availability, which is another kind of non-functional requirement that I will explain later within our system. Now what we want to do right now is to go to source code and do some practical examples. What I want to do to create, I want to create a simple service. I will call it like service. And then I would run multiple of them, maybe 2 would be enough. Then I will install a software, a load balancer, and I will configure a load balancer using Nginx. And I would start sending requests to each one of these services, or actually to the load balancer, because the load balancer would be the proxy or the man in the middle of our system. This is the entry point, and then load balancer, we would expect load balancer to distribute the traffic between the existing services. So let's do it.